First of all, thank you so much for coming to my talk. I understand that right now there are some other there are other great speakers too also talking about reactive programming or some form of reactive. So thank you so much for coming to my talk. I'll just introduce myself quickly. My name is Mary Grygleski. I'm from Chicago and I work for IBM. I'm a developer advocate with the Java developer advocacy team. So we have a booth out here too. So if you haven't visited, please do consider stopping by and get swags and learn about different products. So my specific area as such has been doing reactive Java and kind of related. I've also started doing some more machine learning as well. And in fact, I will share with you a talk that I recently did actually in Ukraine and in Europe too, with a co-speaker from Ukraine, specializing in our socket, which I will also touch on. So, but may I first, that's right, so that's my day job with IBM. But at night, and my night job, or other job, is actually, I'm also the president for Chicago Java Users Group in Chicago. So if you're ever coming to Chicago, please do consider visiting us, and we have a big community there and quite active and trying to make it even more kind of good for the community, yeah. So as such, how many of you are also meetup participants too? I'm curious, yeah, you go to meetups. Yeah, that's a great way to kind of come together as a community and share knowledge. And you can also, if you're ever interested in becoming speakers, sometimes a Java users group, for example, like mine, we will have lightning talks too, that for participants to sign up. Lightning talks are 6-7 minutes of talk, and you can practice and become good at it too. So anyway, so that's a bit of a introduction about me and my community work involvement. So today I'm here to talk about reactive streams. But let me first ask you too, how many of you are already working with reactive programming or reactive systems in one way, form or the other? So yeah, a few. So I see a few hands. So may I ask you, are you working with Spring Reactor maybe, mostly? Yeah, or ARCA? Any of you working with ARCA too? Oh yeah, ARCA is a bit, I have to say, it's a bit kind of more complicated as such, very sophisticated. It's a kind of different model, as I'm sure you're aware. And then how about Eclipse Vertex? Anybody working with Eclipse Vertex? Okay. And then how about, have you heard of our socket too, Reactive Socket? This one, that's okay. I'll talk a little bit about that. So yes, as such, it's kind of a lot of implementations for this specification. So that's what I'm gonna go talk about. And I'm assuming that some of you, if you have not had maybe too much exposure at this point with reactive, I'm also trying to make this talk a bit, including some more basic concepts. So bear with me if you're already familiar with it, that I will kind of make sure everybody at least can get some understanding common understanding. So, okay. So as such, I'll start. So I name it thirst-quenching streams because reactive streams actually is a specification that comes out of these reactive systems, kind of a area of computing. And as such, as you are aware, and I believe that that's why you are curious about this, because there have been so much talks, so many buzzwords and people talking about reactive. So I'm sure that's why you're coming here trying to figure out what it is. So some of you, I guess, figuring out. So I'll just bring up some concepts. As such, I did a talk mainly last year too. When I first joined IBM, I started doing talks and then was in reactive systems and reactive programming, a bit more introductory. So I'll bring in those a little bit too, so to kind of get some concepts kind of straightened out for some of you. So as such, yeah, there's reactive programming and then also reactive systems. And then now the talk is about reactive streams. So broadly speaking too, we have reactive programming, which I think you have heard of. And then there's, in general, for Java, Java supports reactive programming because there's also starting actually with streams support in Java 8, you see more libraries coming out. So as such, there's Spring. Spring is supporting reactive streams, and it's kind of confusing too. So as such, right, reactive programming, what it is that it's kind of a specific niche area of computing, essentially deal with asynchronous processing, event-driven kind of processing. And now, then there's also reactive systems, which I like to also kind of point out is slightly different. Well, kind of strictly speaking, you don't want to mix the two. Reactive programming more deals with your programming. You're maybe in a single microservices, you're applying reactive programming skills and techniques. And very often, they make use of functional style. Well, actually, that's what it is. You have to make use of functional style of programming to do reactive. Because as such too, we are now looking at this programming in a new way. The new way is that you're not the traditional way, in which is more blocking. So if you know that in general, right, like a hello world, you might kind of come in, you do a hello world as like a main routine or main method. Then you just like take the argument and then you do then you do like print line and say hello somebody, pass in your parameter. However, doing reactive, you can actually be very precise and very elegant, because you can just have one single statement and then you take in the input. For example, in the RxJava, you do like an observable or flowable. Then you take the input and then basically you can then immediately like do the processing. For example, like we call like operating on reactive on streams, we use operators. So like using a map operator, for example, you take in the argument or you filter something out from your stream. That's what you do, and you operate on that stream, and then you can immediately like subscribe or consume the result too. So it's pretty precise. So that's kind of in a nutshell what it is. And the thing is with reactive systems that it deals with a bit higher level, because then you're not just dealing with, say, one component, you're dealing with a system as a whole. And as such, it actually brings you into like concurrency, dealing with parallel systems. So as such, as you know, those areas are complicated. Traditionally, like before hardware has become more sophisticated like today, where we have like multi-CPU systems, multi-core systems. It used to be simpler when you have maybe one single CPU or just one core or something in this machine in our current, in the previous generation of hardware. But today we have like containers and virtual machines and everything. So it kind of really pushes the whole software world to go further, to take advantage of the hardware in order to kind of provide, to really make full use of it. And then that will kind of support like concurrency much better. So that's more like reactive systems. And then I also want to I have kind of like in this slide to talk about like reactive manifesto too. So essentially too, for reactive systems, it's pretty much, there's a spec out there called Reactive Manifesto that talks about the 4 tenets. And essentially it's talking about systems needs to be more responsive. By responsive, it means request comes and your response needs to respond in a timely manner. And then it also has to be very resilient. So if something goes down, it needs to be able to bounce back, recover very quickly. So that's another like characteristics of reactive systems. And then also scalability, because now we're kind of dealing with concurrent systems, and you can have like multiple instances, let's say, of the same thing, streams, you're handling all of it, and they need to scale because you have more requests coming in, then you need to have more resources being able to process those requests. And then if request goes down, then your resources needs to kind of adjust accordingly. So it's very dynamic as such. And the whole system too, reactive systems, essentially you're dealing with everything, they're microservices kind of style, or at least so, that you have components all running individually, but they're all synchronized. There's some mechanism of making them able to coexist kind of in a very synchronized manner. And that's, as such too, is really like it's a message-driven model. And there's also differences, minor differences. Well, not minor, but when we talk about reactive too, we bring in like event-driven messaging, and there's also message-driven. So there's some subtle differences between the two, right? Event-driven is essentially, you can deal with like pops up kind of systems. Events come out, then it doesn't tell you where the messages go to. It's up to the people or like you have subject, let's say an object, you have like emitting events. So it's up to those subscribers who are interested in your events, you subscribe to it. So it's like in a RX reactive extension kind of terminology, it's observables and observer like that. So that's that. And then, but then for message-driven systems as such, the messages have two distinct requests, the sender and the receiver, they are known. So the addresses are known between the two. So that's kind of a bit of the differences. Anyway, so now I'll then get into the reactive streams part. Sorry, I keep talking. So reactive streams as such is specifications that basically lay out the guidelines for how messages should be like communicate in a reactive systems. So that's as such is a specification that's basically led by currently, actually I also have to bring up, recently there's a foundation that's kind of formed out of it, and it's called Reactive Foundation. And Reactive Foundation basically is born out of underneath the Linux Foundation umbrella. So currently, Reactive Streams deal more with, first of all, Reactive Streams, to summarize, is basically defining a standards of processing asynchronous messages and dealing with back pressure. So, and are you familiar with back pressure? I guess, yeah, most of you. Okay, so I very often when I talk about back pressure, I like to bring in this couple examples, but one of which is that when I was in a conference in Raleigh, North Carolina, a couple months ago, actually they gave like drink tickets, right? Like us, we come here, you get free drinks, but they give us like everybody drink tickets, but yet at the bar there are only like 2 bartenders for like 500 people in the bar. So I remember when I look at it, I said, this is a good example to explain what back pressure is. So you can tell you have like so many requests for your drinks, but there are only 2 processors in this case. But of course, in the computing sense is that what we do is maybe, traditionally we will increase the number of threads and take care of all these processes. So as such, kind of coming back to this Reactive Streams is trying to address how do we manage like back pressure. You don't want the flow of data coming in as streams, keep coming, and then the ones processing it will be overwhelmed. So the idea is that you want to balance it so that you aren't overwhelmed. It's what Reactive Streams, to summarize it in a kind of layman's, verbiage is, that's what it is. So, okay, so then I'll go into, then talk a little too about the reactive programming, back to a little bit. So this is just a marble diagram I got from the Reactive Extension. So this is talking, when we talk about stream processing, we kind of represent, your stream is like the line up there. And then the second one is talking about, here you have events, they are marbles, represent some events that needs some action. And this one is a perpendicular, it means it's just a stream with a very definite timeline to it, it ends there. And then the third one in here, it's basically, it indicates an error event, like an X in here. So in reactive programming, when we talk about events or error itself is an event, is a first-class citizen that needs to be handled accordingly too. And then the bottom one in here is that it's just a stream that is actually an open-ended stream. You can it keeps kind of receiving events to it. So that's quickly. And then just now I also mentioned too about how do you kind of work with data in a stream is essentially you work with operators. So this is just a very basic example, just using a map operator. What it does is it transforms the data that comes in. So over here is that you use a map operator, it's functional style. So that's where the functional side comes into very handy for doing reactive style of programming. In this case, again, I kind of, here just kind of put it in picture. So you see in the code, you do observable, basically have input, and then you do a .map operator. It operates on it, but specifying that it is a function. In this case, multiply your data by 10. So for each, it's basically, it goes in and multiply by 10, and then basically then your consumer will do an immediate, like subscribe to it, you consume it. So everything kind of can be done very neatly, kind of very cleanly in one command line statement. So that's kind of like highlights of like reactive programming. And I'm sure if you have been to Venkat's talk too, he has had a couple of reactive programming. He really, functional style programming, he has highlighted a lot of these advantages of doing things the functional and reactive way. So, okay, so this is just an example. So we'll go and then talk a little bit too, again, back to reactive streams and why do we need that? But because you may be thinking, well, there are already systems existing out there, you can use threads. And so why are we doing reactive? And as such, and what are the problems we're trying to solve? It's basically, ultimately, it's really concurrency problem. Like that we're trying to solve, and parallelism. But I just want to point out too, concurrency is really dealing with multiple tasks all at once. But parallel is basically doing multiple tasks all at once, say in a multi-core kind of hardware system too. So essentially, those are ultimately is the kind of problem we're trying to solve. And for example, like, I guess it's interestingly too, when I was talking to some participants who came to me to my talk, and they're from trading firms, they're actually finding reactive streams and all these libraries are kind of slow, and which I can see, because as such, you still deal with libraries and everything may give you a bit of delay in how it processes. So therefore, like in general, if you are in high frequency trading, and that requires low latency, right? Then in general, companies may still be writing their own threading library to it too. So I just kind of, again, want to point out, Reactive Streams is good, but may not solve all problems. But for example, that would be an area that maybe if you are into like doing trading application, Reactive Streams may not solve your problem. But anyway, so that's that. Anyway, so let me go then. Okay, then now when we get into Reactive Streams, there are also like different models too. So there's this push versus pull model. And as such too, when we talk about streams coming in, then there's like how it travels is basically the two models of push and pull. So in general, too, Reactive Streams, interestingly, is not quite exactly, although there's been kind of debate, which I'm still trying to find out, it's more push. But what happened is that if you're doing a reactive extension RX Java, you would have like, your data coming in observable, and then you do some transformation and you do a subscribe. Subscribe itself is more like a pull, because then you're kind of telling that you want some data, you're demanding it. So in some ways, it's more like you do a pull first and then it pushes down to you. That's more like a pull and push model. But a strictly like push model would be if events are ready, it would just push to whoever is needing the data is a push. So just to kind of explain a little bit more. So push, again, is basically here is just a diagram. It's explaining from upstream to downstream. So it's the producer will emit data, and then immediately it will send it without being asked explicitly to the consumer, those that are subscribing to it. And then for pull is that the consumer will need something, so in translating to code will be you subscribe to it, and basically the producer knows. So then in that case, when it emits data, it will then push it to whoever is kind of requesting it. And that's kind of a major differences between the two. Okay, then now we'll kind of look into a bit more about the Reactive Streams, the specification. There's actually the site too, which I have it later in my slides too. The website is reactive-streams.org. So that will give you information. But if you read that, it seems like it's like not a very huge page. And as such, it also too, if you look into the specification, it is only as an interface. It specifies like 4 interfaces, because the goal of such is they want to do things really simple. And also what they want to achieve is interoperability. So that, you have streams sending data. They always do, what do? They are like essentially like, let me take a look. So over here, there are 4 interfaces, will be publisher and subscriber, processor, and subscription. So those are the 4 interfaces. And for the specification itself, it doesn't have implementation. Although it has a TCK, which is the testing compatibility kit too. So essentially, if any vendors want to implement Reactive Streams, they need to kind of make sure they meet the requirements of the TCK. And anytime if you want to implement Reactive Streams, you have to make sure, that passes. So let me just kind of take a bit look then. In this case, for Reactive Streams, we have publisher. So for the publisher as such, what it does, the only method like interface in there, it will be subscribe. So for the subscriber to subscribe to whatever gets published. And then there's also subscriber. Then subscriber will be, on subscribe. Then it will, do something, react to it, or kind of on next, and then the on error and on complete. And then there's also then the subscription interface. So as such, it defines like basically subscription is kind of abstract too, right? You kind of anytime you have like you materialize like a stream kind of subscription, then that's what it is. And essentially too, subscription will have the request, and then also you can cancel your subscription. And then there's also the processor. So processor essentially processes these the different like publisher, your messages, and then the subscriber side. So that's the 4 interfaces. But I'll kind of go back a little bit. So and as such too, currently I'm sure there are maybe many more implementations, but the major ones that I've laid out in here would be the Spring Reactor, and they actually have and also like RX, the Reactive Extension. So as such, I'm kind of grouping them together, and you may be aware too, if you're familiar with it, is that they're the same group of engineers working on RX Java 2, which supports back pressure, it supports reactive streams. And then the Spring Reactor too, which making use of like Flux and Mono, dealing with streams like that. So I just kind of group them together because they are essentially same group, because all of them methods, everything, they're compatible too between the two libraries. And then the other, another popular one would be Vertex, and Vertex is from Eclipse Foundation. So by the way, too, all of these are open source libraries too. So, and then Vertex too, it comes from Eclipse, and Red Hat is a major contributor to Vertex. And as such, for IBM, we don't actually, on the IBM side, we actually don't have our own reactive implementation. But because of our merger with Red Hat, so we're kind of starting to do more kind of efficacy too for Vertex, the library. And then there's ARCA Streams, which comes from Lightband. And IBM actually still has this agreement or partnership with Lightband, which is, Lightband is the ARCA library. So it's essentially, IBM has it, and it's called like Reactive Platform, is mainly targeted for like enterprise level kind of people using it too. But then now IBM won't continue that partnership, but we still support the ARCA streams and the ARCA open source libraries. So, and then there's also then MicroProfile. MicroProfile, as you're aware, that comes from also Eclipse Foundation. And MicroProfile, and as such, IBM's involvement is quite heavy into contributing to the open source libraries. So, and MicroProfile as such is primary focus is for microservices, to deliver microservices, and using like, a systems of, in this case for reactive streams, it started supporting reactive streams since last summer. So it's a kind of newer kind of support for that. And then there's also this relatively newer library. It's called Reactive Socket. So that's actually quite exciting. I just want to share with you, but let me kind of step through each one of them again, because I'm kind of highlighting this, and I thought, I have some slides that go through each one of them. So let us go back. So as such, right, let me kind of go back. Sorry if it's kind of getting confusing. I know I'm trying to jam a lot of different libraries, but just want to kind of more like give you an idea. So Spring Reactor, let me go back. I believe that if you're already like a Spring shop, if you want to get into doing like reactive stuff, I kind of would think that would be more like a more natural kind of transition into adopting reactive. You may want to consider Spring Reactor. So as such too, it has the Reactor core library, and basically too, like you have heard of WebFlux and such. And Flux itself, essentially, it streams, and it handles like any kind of processing. You can return a flux, like the streams that comes back, and the flux is basically from 0 to like many streams in your return. And then there's Mono too. Mono essentially is a return of either 0 or 1 stream. So that's kind of like the highlight of that. And basically too, Reactor also then support like non-blocking, like inter-process communication with the Reactor NetD project as well. And it's also very highly suited like for microservices architecture too. And it's back pressure ready, and you can do HTTP web sockets with it and all that too. So yeah, so as such too, it supports also the R socket, which I'll talk about it later. And then Reactive Extension, I just want to also bring it up again. As such, if you're an Android developer, you're probably more familiar if you do Reactive, because essentially RX Java it's kind of supports Android. Let's see. So as such too, for RX Java, essentially it has flowables in version 2, and that's the observables that support like back pressure. And I think I already kind of gave examples of it. It has a lot of operators that operate on data in your stream. So yeah, and as such, yeah, that's what the highlight of it is. And let's see. Okay, then I'll just jump to like talking about Vertex too. Vertex, again, I talked to already about its Red Hat heavy involvement, its Eclipse Foundation project. And it makes use of what it calls a verticals model. And also like it in the runtime, it has an event bus that processes all the events. And it has its own runtime too. The very kind of characteristics of Vertex. Its strong point is that it's a polyglot framework, meaning that you can actually, you can have code in Ruby too, that actually you can kind of have your same application have different language libraries, and they interoperate very well too. So that's like a kind of a strong strength of Vertex. So that's that. And okay, then then I'll kind of talk a little about like ARCA streams. So ARCA itself too is slightly kind of different too. It kind of, in my mind, right, sometimes when I think of ARCA, it almost seems like they want to be kind of a ninja kind of thing. They want to be kind of different. They are very sophisticated. If I think one of you have worked with ARCA, it's not that easy to kind of know it, but once you know it, it's a very sophisticated framework. And the nice thing about it from a coding perspective, you actually end up, you don't need to code as much, but you do need to understand all of the stuff underneath and be able to know how to configure, and it works very well with, say, in a cluster environment. So it's basically a very cloud-ready type of library too. So it's probably more suited for really more highly sophisticated kind of application, I would say. But it's still good. So as such too, though, their API is very minimal and very consistent too. And again, they call themselves like explicitness over magic. And they support like different pieces and retaining functionality of each part. They call it composition that they take on that model. And so they have also like tooling to handle like back pressure in stream processing and buffering and transformation and all that. So without going into too much detail, I'll just thought I'd give you that kind of a quick intro. And now too, then I'll also talk to then about another implementation, again, is MicroProfile, and that comes from Eclipse Foundation, and IBM is heavily involved with that. MicroProfile as such too, how many of you are already working with MicroProfile, maybe? Yeah, okay, no problem. I just kind of wondering how much I should go into talking about it. Again, as such that MicroProfile is, as such is, the focus is on helping you to build a system of better system of delivering like microservices. And as such too, the strength of it supports like location transparency. And that's one thing especially in distributed systems, you don't want to worry so much about, location transparency as such is that you basically tell where you have so many components. So you don't want to like worry about, where each one is. So you basically use names to identify all of them, so that it has mechanism for you to easily kind of maps like you name your different components, and they kind of take care of all of these underlying kind of complexity in terms of on the network layer for you. So the location transparency part is pretty good in MicroProfile, and it also then has this concept of like temporal like decoupling too of MicroProfile. Okay, so that's that. And then our socket, I just wanted to kind of get to this because I was kind of getting excited to learn about it. It was a couple months ago because as advocates, I traveled to different countries too. So I actually got to know this one guy who actually works for Netify, this company. They're based in California, a startup company, and they are very big into like pushing for Reactive Socket. So as such, Reactive Socket too is a binary protocol and basically using on byte stream transports. So I think if you're more application level programming, you may not need to deal with it as much because it's a bit kind of a lower level kind of library. But as such though, if you want to write your own kind of socket level kind of functionality, this also may be a way to go if you're thinking of very, very like highly responsive type of libraries. So as such, just giving to you, because the nice thing about it is it isn't like language specific either. It actually supports Java, and then obviously Java, and then also JavaScript as well. And then it is actually very efficient too. And basically, let me see, I'll just take a look. So it basically uses this binary encoding, and the nice thing about it too is that it has 4 models of kind of like their operation, their processing. So the 4 models are like you can have like one single request to one response, kind of like that model, or you can also do like fire and forget. So it'll be like more just requests, and the client doesn't expect you any return results. And then there's also a request, one request, and then they can have many responses back. So it's like a request to stream kind of model. And then the nice thing about this is that it's basically they have what they call a channel, kind of bi-directional. So in other words, you can actually have a connection kind of remain like open and maintain the persistence between the connection too. And that's bi-directional. It's all asynchronous too. So it's kind of a pretty interesting protocol. And over here too, just give you some idea too. And again, this is the Reactive Foundation and the ARCA socket. And these are the companies too, like Facebook, Netlify, Lightbend, Alibaba, Cloud, and Pivotal, and vLingo. So over here too, that's what it highlights. It's an open source layer 5 and layer 6 communication protocol based on Reactive Streams. And it's really fast, and then it takes care of like streaming and resumption, cancellations, and it eases development. And the big thing about it is the reactive back pressure part too, and flow control. And then, again, I also mentioned about language and platform, and also transport too. You can run on TCP, and also like WebSocket, and also Aaron too. I haven't used Aaron, but then if there are folks like kind of into that too, it also supports it. And then I just want to kind of quickly bring up too, of the 4 models, for example, there's that channel model. So, okay, I'm sorry, maybe I'm jumping around here. It's just I've been kind of like quite busy with my travels. So, and I'm still in my mind, I'm still thinking of that presentation I did with the Ukrainian person working for Netlify. He's actually a more ARCA socket specialist. So that was really neat too. So what we did was in that talk, and maybe next year I'll do that presentation here, is we teach, we develop a multiplayer Pac-Man game. And as such, we make use of reactive streams, because as you can see, multiplayer Pac-Man, you have many streams of data. You have ghosts, you have Pac-Man coming in. Multiplayer, anybody can sign in and play that game. So all these streams you need to be processing at every moment where each objects are on your grid, right, your playing thing. So what we did was, not that we were machine learning expert, but we decided let's use machine learning. So that's what we did. And so how many of you actually are familiar with machine learning work too? Oh, so some of you are. So, oh, cool. So basically too, we did some research. I was hoping to use IBM Watson, but then as such, the Watson doesn't have the reinforcement learning part yet, so I couldn't use it. But then turns out that we actually we found an implementation by a research project from Europe in Madrid. So that was actually exactly what we needed. But we did some like comparison too. We were like doing comparison of using different ways, right? For machine learning, you can do like Monte Carlo tree search or using like just rule-based. But those are, if you can imagine, you play a game, you kind of code it. If you do rule-based, it's huge. You need to like know the domain knowledge and do like if then, if the Pac-Man is here or your object is here, you have, you can only go like right, left, or up or down. And then you have like different state, right? You need to capture all of them. So if then kind of rule-based is not possible, so then we go into doing, okay, let's do a Monte Carlo tree search. But as such too, you do need to know also like the different state too, like, you need to capture a lot of information and build up your knowledge repository. If you're familiar, like machine learning, you essentially, you're learning as you go. So then we look into, well, how about this neural network, or like using like genetic algorithms, evolutionary, but that also will become an overkill for playing a game like Pac-Man. So we kind of basically decided, okay, let's use a reinforcement learning, and as such, reinforcement in machine learning, I mean, giving you, not that my talk is about that, but just giving you some idea, is that more like, you're learning to play the game. You don't have information yet, but you keep moving and you get rewarded as you go along, then you build up your knowledge base, kind of like that. So essentially, you can imagine too, we're collecting data then from many different moves by many, different objects on your playing board. And so that too, like we kind of eventually use like ARCA socket to handle it, and kind of, it was actually quite efficient. So again, like ARCA socket, one, multi-channel kind of scenario, that model you can use for like a game playing like strategy. That will be one thing. And then you may also be asking like, well, then reactive streams, what other good is it for? So as such, you may be already aware of that there are IoT, a lot of IoT applications now too are maybe collecting data from like different sensors, setting up in an area, maybe agriculture, and that will also be a good like use case for using reactive streams too. So I just want to give that information to you. Okay, so then I'll kind of move on a little then. Okay, so some additional information too, and this one doesn't support reactive streams directly, but I like to also point out if you're ever into doing streams, and there's also another option, which is OSGi, push streams. And are you familiar, or anybody work with OSGi? Maybe not. Okay. Anyway, it's also it's a bit of an older library. It's essentially if you use Eclipse, the IDE, Eclipse Foundation, that IDE is actually all written underneath the libraries, all the modular. It's very modular. Actually, it's an older library. That's the OSGi. I think it stands for Open Software Gateway Interface. The name is interesting, but if you look it up, you can kind of take a look too. But as such, too, OSGi has what it's called a push stream specification. Is R7. So just thought I'd give a little bit information to you too, if you ever get into doing streams processing. But so just give you some comparison too, because we were talking about reactive streams. So what differences are they with push streams and OSGi? So if you compare the 4 interfaces, reactive streams, and also I didn't mention earlier too, is that reactive streams essentially is built on the Java 9, the Streams API too. So, and as such, the 4 interfaces it maps to, like for the event and data source, right? There's publisher. Then it maps to push streams will be a push event source. And then the data, the sink, it's basically we call it the sink is the subscriber part of reactive streams will map to the push event consumer. And then reactive streams has the subscription, it maintains the connection, and push streams, and that's one difference between push streams and like reactive streams. Push streams, they have what they call auto-closable. So if you the streams kind of keep going, it will know how to close itself, and that's a feature in the push stream OSGi specification. And also another thing is that with OSGi, the push streams, they also has its own implementation. So it's basically all developed by OSGi. So, and then there's also then the pipeline, in this case, reactive streams, we call it like a processor, but the push streams is essentially a push stream interface. So, okay, so that's that. Okay, so now, I'm sorry, I keep talking, and so you might be thinking, oh, well, she keeps talking, and do we see any code? So I have some sample too, I can show it to you of like using like reactive streams, what we can, how can we apply to it? So I'll just kind of give a quick thing, but in this case, I'm using, because I was more advocating for ARCA, for a lightband platform. So this particular usage scenario is actually using ARCA streams. And then ARCA, the lightband also has this library, it's called Alpaca. Alpaca is like a connector, connecting the streams and then to, in this case, CSV files. So this particular demo is just very simple. It's essentially watching a directory. If there are any changes in your files, in specific like files, then it will basically like notify you, and you see responses that that it senses it. So it's kind of using a reactive streams kind of approach to do it. So okay, if you can give me a second, I just need to switch over to the other to my IDE. So okay, let's see. I think I have to. I don't think this will do it. Yeah, I think I have to stop this for now. So okay. Let me, I can never get this quite right. Actually, let me also do this one thing, because I have some notes in here too. Oops, sorry, I didn't have enough time to set it up sooner, so that's why it's a little bit kind of not very organized, so I apologize for it. But do you have any questions, or does it make sense? And maybe I can ask you what I've talked about. Does it seem to, oops, I'm sorry, not able to do this, sorry. You're welcome to ask questions too, so yeah, and I just want to make sure that things are making sense to you, so. Or how many of you are maybe thinking of maybe adopting more a reactive approach in your systems that you're working on? Are you considering that, or maybe mainly you are just wanting to see what's out there? I'm curious. Quite, yeah. So yeah. You're considering like using, or are you already using it? Oh, okay, yeah, okay. Cool. All right, let me just quickly too. I just need to get this up. Okay. Okay. Let me see how I can bring that to the screen here. Maybe I'll do this one thing. Okay. I can't. Maybe I'll bring. I think it's the other. Somehow I cannot. I think I'll make it mirror or something. Yeah. So. Okay. I'm sorry. Let me just take a look. Sorry. I think I just have to change the configuration in here. Okay, display. Okay. Okay. Okay, I'm sorry. Okay. Okay, good. Yeah. So at least if I mirror it for now, then we can see it. Okay. Let me go back to here. Okay, you can see it now, right? Yeah. Okay. So just a kind of like quick thing to kind of step through this. And again, this is just a simple CSV file processor. So in this case, I'm using ARCA to do it, and then using Alpaca for the connector. So let me kind of quickly too. Okay. So basically, just wanted to point out. So you can see too, in this case, we basically just set up, right? There's a data directory and all these, and there's also an application conf file in here just to show it to you. So we bring this up as a server just running on 8080. And the data directory is a /temp/data. And these are like polling intervals and all these. It's just a dummy app kind of thing. So these are like our configuration here. Can you see okay, or is it, yeah, okay. Okay. All right, we'll go back then. So that's the configuration file. So we're reading all these configuration. And then basically too, over here, you see that there's our source here, the directory change source. We basically then essentially create this thing. It's it's basically how can I say? So it's actually already available. This is from Alpaca too. So it comes from Alpaca, has this like directory change source. It uses basically underneath it. It senses that if there's any change to it, there's already a watch services underneath is what we're using. And then you can then see the flow in here. So the flow, you can see this is all like using like a reactive functional style of programming. So these are the paths, and we basically create the path. You see that we do the flow and we do the create. And basically what we do is we do a filter and then pass in the CSV file creation event. In here, you filter those events, and then you print out the file name. So like that. And then this here, basically too, if the file itself, the file name, it ends, with the file name of CSV, then basically, you then do is it CSV file? You basically try to find out the file that gets created in your directory. Yeah, so you got it. So, okay. So essentially, that's essentially what it is. It's actually got a bit more to this app, but I think I may be running out of time. But I just want to show the part of this, show you the monitoring part, like how it runs. So in this case, I'll just do this in here. I think it's almost lunchtime. So okay, so this particular app too is already there. It's simple enough. You can just do a Gradle like run. And so, yeah, must be lunchtime. So, yeah, no, thank you for still staying. Okay, it's just a very quick then. So over here too, then we bring up this server. It just goes to localhost 8080. So we'll just show it to you. It's actually already, I was testing it earlier. It may not actually be working, but it's simple, some simple thing, and just say, okay, the connection is opened. But actually, the thing is, it should be better. It should give you like another thing, but let me do it again. I don't know whether it's cached or something, but anyway, so this is what it is. So let's say then, if we drop a file into it, I will Actually, let me go back so then we can have this one over there. Oops, not there. Okay, we put it in here. So we see that that's the console. It sends that, okay, your connection is open. So now we go over to our directory, which is in here. I put it into /temp/data. So it's /temp and then the data. Right now there's only one file. It's actually supposed to read it, but for some reason it may not be doing it. But let's say we drop a file into it. I can copy. I have a bunch of files too that, actually, let me go to the other one. Oh, okay. Block. Yeah, okay. So there's this a bunch of data too. Sorry, I should have sample data. Okay, so this is a bunch of like sample data. So we'll drop this. Let's say we copy another. This one. Actually, let me do this. Copy this. And copy this file into the /temp or /temp/data. So then once it's dropped, see, it sends it. So that's what the thing is. So yeah, so basically then it will then read through and process it, what it is in this particular example. So yeah, as such, I'm sure it looks like I only have essentially 5 minutes, but rather than going into all the details, I think it looks like everybody is hungry, so I don't want to hold you up. But if you want to talk some more about it, and of course I'll make the source code available for you to look at too. Again, this particular example is simple enough, but just want to illustrate to you using Reactive Streams. It's very simple. I show you the couple of things, and it's kind of can done its job pretty quickly. And you know, the sky is the limit. You can actually make use of Reactive Streams and do a lot of creative things. Yeah. And I hope to come back next year, maybe do the machine learning, or maybe I'll come here, talk to Pratik, right, about the Atlanta jug, and if you're in Atlanta, I can do the machine learning sample interoperability with Reactive Streams too, if you're interested, yeah. And please follow me too on Twitter, and let me kind of actually go back to this, because I actually have one more slides, and I will just run it. So then if you want to take a look and stay connected, current slide, okay. Okay, so this is some information, but I'll make my slides also available too. And would like to also point out there's one particular link in here, which is the IBM Cloud here. Currently, I'm not running anything on the cloud yet, but I hope to with my machine learning, that particular example, we have a game server that handles the Pac-Man. That one I like to deploy it onto IBM Cloud. But as such, IBM Cloud is free. We have a free tier. So I'd like to invite all of you to sign up for a free account. I think right now they are giving you some limited credit, maybe $200 for using OpenShift too. So that's a good thing. It may require your credit card. I'm not sure where it is, but it won't charge you unless you use something that costs money. So I'd like to invite you to that. And there are plenty of things under IBM. I mean, everybody looks at IBM, it's like they've got everything in the world. It's like all the gadgets, and may not be all useful for your use, but you're welcome to take a look into those. So that I'd like to point out. And then these are all the reactive links too. And also the push stream, this one. And then this one, I like to invite you to also sign up for our IBM newsletter too. Different topics too. And you can unsubscribe anytime. So. And then some more resources on the Reactive Streams resources too, over here. So this, I have this page. I have Spring, RxJava, and RSocket. And then the next one I have ARCA, Vertex, and MicroProfile. So yeah. So if you need anything, please follow me. And yeah, I'm usually quite responsive too. If you have any questions, I like to continue the conversation. There's just so much you can do with something that's kind of so new and exciting. So. Yeah, and so thank you very much, and I appreciate, again, you coming and staying too. So, okay, have a good day. Yeah, thank you.